Hi again. Okay, so we are going to do a second example of finding derivative of a function. In this particular case, the function will be so example 2 for 2. So our function in this case will be f into x is equal to square root of x. Find f prime of x. So finding the derivative of this using first principles, we will follow through and do the same thing that we did in the previous example. So we will say f prime of x is equal to limit, remember, of the function of x plus h minus f into x over h as h tends to 0, right? So in this particular case, we will say this is the same as square root of x plus h minus the initial function root of x over h. So in cases we have something of the sort, what we typically do is that you want to take the square root from the top, so you put it in the bottom. That way you can understand the limits of your function. So in this particular case, what we would do is that we would say, remember, if say you had something of the sort and you wanted to take the square root from the top, you can just multiply it by the conjugate of that expression. So in this particular case, say if you had a plus b, its conjugate is a minus b. So what I would do is that I would come here and say square root of x plus h minus root of x over h with the limit as h tends to 0. I keep forgetting limits, so please remember that whenever you're writing, include the limits. H tends to 0. It's a common mistake that I do. I tend to forget the limits. So times the conjugate of this, which will be square root of x plus h plus square root of x over the same thing, so that we take it away, so that this expression here is equal to 1 essentially. So then this will be x plus h plus square root of x. If you multiply through this, what do you end up with? You'll end up with something of the sort. Limit as h tends to 0 limit as h tends to 0 of what's going to happen here. So if you multiply that through, you would have of square root x plus h plus x, the whole thing times h in the bottom. So this divided by that, what do you get? Actually, it's not a multiplication. We're not going to divide anything. So we'll say, so we have this. So bottom multiplied, you get this, right? Top multiplied, you just have, remember again, we said a minus b times a plus b. In our other videos, is the same thing as a squared minus b squared, right? So in this particular case, you're just having essentially root of x plus h squared minus root of x squared, which takes away the square root, and you just have on top here x plus h minus x. So the x cancels out, subtracts from each other. The h cancels out from the top and the bottom. So here you end up with the limit as h tends to 0 of 1 over square root of x plus h plus root of x, and as h tends to 0, you will eventually end up with, essentially as h tends to 0, you'll have something of the sort root x plus root of x, which means you'll have a half root of x as your final answer. So if you remember from our previous question, so this is your answer to the problem finding f prime of x for the function f of x is equal to square root of x. But remember, if from our previous examples, if somebody said, what is the domain of f into x in this particular case? Remember domain? How do you find domain again? Do you remember? So we drew those axes and figured out what is inclusive, what is not inclusive, when to use open-ended brackets, sorry, parentheses, or when to use closed brackets and stuff like that. So if you're not familiar with that topic, you can go back and review it. But the domain of this function in this particular case would be, for instance, 0 to infinity, because you can put in any number here other than 0, but that is greater than 0, and it will give you a well-defined real number. And that's the meaning of domain. So, but this is not part of our problem, so I'll take it off. That's a by the way to remind you guys about domains and how they could be integrated into any sort of problem going forward. But your answer is that.